right, good morning, everybody. It's your moderator today before I hand over that job to that good-looking gentleman in the first row. My name is Ansgar. I'm working for the Eclipse Foundation, being responsible for our automotive ecosystem, so mainly the SDV one. I'm glad to see that we still have some leftover energy in the room. We do have two fantastic talks this morning. And it's my pleasure to announce the first of the two talks which we have this morning. And that talk is going to be about test automation using SDV Toolchain and Eclipse Symphony and Automotive CI/CD Toolchains. I'd like to announce my first two speakers for today, which is Hannes Fuchs and Felipe Plezado. I'm not sure if I pronounced that somehow in a Portuguese way. So Hannes is working for AVL. He's a software architect at AVL, does a lot about smart calibration, virtual testing. He's going to have that talk together with Felipe. Felipe is working for Microsoft as a program manager, a long-time SDV community fellow. And welcome the both with some warm hands on stage and learn something about testing automation, please.
So hello everyone, thank you for being here today and having interest in our talk about test automatization using Symphony and Automotive CI/CD Toolchains. So Philippe and me are presenting this talk today to you. Let me give you a short overview. So first we will start with our motivation for the talk. Then we will go into a selected use case, which we think should be interesting for every one of us. Then we will give you a short overview about the architecture we created. Then we'll dive into a live demonstration, and finally we'll wrap it up with some lessons learned and some key takeaways. So let's start with our motivation. So first, open source enables us to develop software more efficiently, to collaborate easier because we, of course, can share ideas, share requirements, work on issues together, keep our software flexible and customizable, and then stay independent from logins and also flexible to change the software to the needs of our customers. Our overarching goal is here to create cloud-enabled, sorry, I have to close here this one. Create cloud-enabled toolchains for a better collaboration and increased efficiency on automotive testing. So what does AVL do? So we are creating testing solutions for the software-defined vehicle. We keep our solutions via open source building blocks adaptable to the customer environments, and we collaborate on non-differentiating building blocks. So the two projects we're most interested in is the OpenDOT and the Symphony project. So maybe Felipe.
Yeah, so Microsoft has been a member of the community of the Eclipse SDV working group for, I would say, since the creation of the working group itself. And you can ask why Microsoft is on a software-defined vehicle working group. So we look at the community and we look at the open source community across multiple ecosystems. Of course, the automotive one being quite important one for Microsoft. And we work with the ecosystem to bring our innovation about large-scale deployment and building of software for our, that you might recognize, for example, from Azure, or from even our sister company, GitHub. In these past 3 years, we have been making quite substantial contributions to the several OSS projects, some of them that are there highlighted that we brought to the community pretty much since the first community days, like Chariot, and then we brought some other projects like Ibeji, which is an in-vehicle digital twin. But most recently, at the end of last year, we brought Eclipse Symphony, that we are going to talk a little bit about it. And we see Symphony as a key differentiator to help build the next generation of software when you need to orchestrate multiple tool chains. And if you look at the current state, and we all have different tool chains, getting a solution or a platform or a set of components that allows you to bring your investments on those solutions and apply it to different use cases giving the developer the option to keep and work with the same APIs, the same object model, gives a lot of flexibility to create these use cases. The other contributions we have made, as you might have heard during these past 2 days, is of course the Azure real-time operating system that now today is Eclipse ThreadX, a safety certified RTOS. But most important for us, what we really do with the community is work with you that are the tier ones, the OEMs, essentially the partners, to build software. And of course, ideally, if you see value, run that software from Azure. So our 3 pillars of collaboration is about innovation, is about working to advance the state of SDV and the SDV working group so that we can achieve the goal of bringing open source software to a quality state that gets you into a qualified functional safety and certification. And then, of course, with all the investment on generative AI that you might have seen across, we are starting to bring some of our expertise on large language models, small language models, copilots, GitHub copilots, and how we can help, again, develop the next generation. During the demo, if everything works well, because my laptop is not able to connect to the network, to the presentation, we are just going to highlight how we took the domain-specific language that AVL has been working on, which is an open source component, how we take Eclipse Symphony to orchestrate a set of tools and tool chains for that domain-specific language, apply to one specific use case, and then, of course, bring a perspective of a copilot and how the copilot can help us with that. So, Hannes, if you want to move.
So let's look into the use case we selected. So automotive cybersecurity testing. Everyone of us knows software, the amount of software in the vehicles is growing, the connectivity is growing. So every modern vehicle is in-vehicle security. We have connections to mobile phones using different interfaces, but there's more. We also have the charging stations where we have connections in place. Then we have vehicle-to-vehicle, vehicle-to-environment connections, and we also have more and more the connection to the cloud. If we look into these fields in more detail, we see that those are quite different areas. So we have different standards applied there. We have different protocols, different regulations. So it's quite challenging already. But then there's more. Depending on in which market the vehicles are sold, you have on different levels, different details of the regulations. So in some areas you have just the vehicle needs to be secure and you need to explain why it's secure. In other areas, there are even test catalogs and prescriptions for tests added for different parts of the vehicle. So if we look now, there are also more challenges if you want to implement solutions for cybersecurity testing. So the thing is, the test, you want to have cover these test catalogs, but the tests need to be specific for the system under test. So you need to consider the EE architecture, the message protocols, and so on. Then you want to carry over the same tests for different systems under test. And this is hard because it involves updating the tests, you need to parameterize, and so on. So it's not just take the same test, run it on a different system. You need to consider and redo it for the whole architecture. Then the scope of testing and execution is often not standardized because it depends on the knowledge and the experience of the tester. If testing is outsourced, you basically also don't have, can have the full trust into or confidence in the test results because it depends on the experience, system knowledge, and tooling applied by your supplier. So also the outsourcing is another effect. In an ideal world, you would get immediate feedback during development about what is the quality regarding cybersecurity. But due to outsourcing, it's not integrated closely. So you have long feedback loops. It takes time until you receive feedback, and that makes development basically more inefficient than the regulations we had already. Yeah, and also what we saw in the news, cybersecurity was not always a priority in the past. So the priority was to deliver a working product. But now with all the connectivity added, it becomes a must-have to keep the customer trust. So what does AVL bring to the table? So we have a suite of cybersecurity solutions for automotive, which is called AVL SecGuard. This has different areas, starting from requirements to the threat analysis and risk assessment, model-based investigation approaches about what attack vectors could be there. Then the testing solution, AVL TestGuard, which we will focus on in this talk because it's about the automatization of testing. And then also lifecycle management of threats. So we create, basically by experts, the implementations of these test catalogs, which are required by legislation we saw before, to cover all these testing needs. And this is basically using the DSL language, which we open sourced in the OpenDOT project. We will come to that and why we use it and what benefits brings us later in the talk. And then we connect this to our DevOps pilot solution, which is a CI/CD pipeline. We focus on automotive testing. On the bottom left, you can see the TestGuard agents, which is a hardware device which is connected to the network, which features different common interfaces from automotive vehicles or components, which is then used to basically connect to the device under test. And the goal, of course, is to achieve a secure system and regulatory compliance. So just to give you a short view how this looks set up on a table. So here we have the AVL test agent connected to some European HMI device, which is here the device under test. So now let me share some insights about the architecture we created. So first, let's dive into the DSL and what it brings to us. So the issues it addresses is that for this carryover of tests to different systems under test, we create this test catalog, but we create it on an abstract level. So each test is defined in terms of this DSL language, and it contains then steps, but like which bus protocols, which, for example, CAN IDs, or system-specific information is not there at this level. And so what it allows us is to then compile this DSL from the abstract level with the specific system-specific information to then get executable tests, which we then can run automatically in the cloud on CI/CD pipelines. It also allows the standardization of the catalogs and then applying the same catalogs of tests to different vehicles, and also achieve then comparability and benchmarking of the security of systems. So in written language, for example, you would have here on the left side steps what could be written in the DSL, and on the right side how it would look like then if you compile it with the system-specific information. Like, for example, taking under consideration of the bus protocols implemented, common attacks known already or exploits known for these protocols, maybe common issues like if a random seed is not really randomly generated, or if you not use a good encryption key, for example, with too less fidelity. Yeah, and also for the if you want to create a malicious signal, like for example on the CAN bus, you can then add the DBC file and the message structure of the CAN of the different vehicles to basically then create meaningful signals for the attack. Now I created screenshots of a very simple test, which basically on the left side is in the abstract form. Here you can see in the DSL you only have placeholders. You don't have concrete values for the different settings. And on the right side, this is compiled with the system under test specific information. And this DSL then can be used by the AVL TestGuard to execute the actual test, where the test is basically implemented in the catalog. So now let's look at the reduced architecture of the AVL DevOps pilot, including Symphony and the DSL. So what you can see on the main differentiation here is the lower side to the upper side. So basically on the lower side you see the part of the solution which is deployed into the AVL cloud tenant, where we then provide our software licenses, the testing catalogs and so on, to the upper side, which is deployed in the customer's cloud tenant. So it allows cross-OEM supplier collaboration, and it even might allow in the future to make cross-OEM supplier pipelines. You can see here Symphony on the lower part, which is used to deploy the customer instance and also to orchestrate the pipelines. On the upper part, you see here now one example of a possible pipeline, which basically contains the cybersecurity testing solution with the testing catalogs, and then as edge devices connected the AVL test agents, where then the devices on the test are connected. So, yeah, I think, and what we discussed earlier, potentially our approach to combine the OpenDOT DSL language with the Symphony for different, is applicable for different testing use cases, or we also plan to apply it to different use cases. So we think that even a blueprint might make sense.
Okay, so when you look at such a complexity of tools and systems, just to come back to this picture, more or less 3 years ago at Microsoft, we start to look at how we can actually build an end-to-end and consistent experience for orchestrating these multiple tools and tool chains that you saw out there. Forget about the part of the cloud. Just think about from a developer perspective. Testing frameworks, domain-specific languages, compilers, multiple builds, multiple repos. How you bring that experience into one, I would say, consistent way of describing the steps that you want to achieve. Of course, have the system work for you, essentially scheduling the compute and the storage that you need to run your multiple orchestration steps. In this case, you are seeing a use case from a cybersecurity test perspective. And how we build this without imposing yet another tool on you guys, right? So how you can bring your tools into that orchestrator. And of course, making sure that we adjust this to the dynamic landscape of ever-increasing new tools. So, and of course, we start doing this without losing our minds and starting to build a very, very large monolith system. So basically, when we look at Symphony, we look at different vendors at different times to orchestrate. We also have different workforce knowledge on our industry and even in cross industries, right? I was in a couple of discussions one of these days, people looking at, for example, TypeScript languages that is completely unknown for an embedded software engineer, right? And he's not supposed to know. But nevertheless, you might want to bring some tool into your tool chain that has some technology that, again, you don't know and you don't have time to learn it. And of course, then looking at different deployments and versions. The Eclipse Symphony is an open source project today, since November, that we basically can run everywhere, can run on any cloud, right? Can run on your on-prem environment, can run your data centers. And the reason we did that is we built it as a platform agnostic set of, or platform. Is highly extensible, so essentially you can build your own specific provider models to integrate with your targets, third-party on-prem data centers, if you want running on AWS, on GCP. And what Hannes has been doing together with us on the open source is actually building providers to take advantage of the Symphony object model and Symphony AI to execute and orchestrate those tests. Works as a standalone on Kubernetes. So if you want to run on your Kubernetes instance, it's a CRD. If you want to run it as a standalone API, for all means, right? It's very lightweight, and basically the Symphony API host is around 90 megabytes of size, and it's basically what we describe as the full agent, because the full agent or the API host is basically the same process. It's just a configuration. We also built a light agent for Symphony. We built it so the Symphony itself is written in Go. but this agent that we call it Light is built in Rust. Is under 4 megabytes, which I understand for some of the embedded developers, while I was talking with Ansgar a couple of minutes ago, says, oh, that's too big. Yeah, fair enough, I understand that point. But it also has an agentless mode, right? So from your control plane or orchestrator, you can also push those workflows or steps or execution towards the agents that you register. So this is a little bit of Symfony. So Symfony has quite, I would say, 4 key capabilities. One of them is, of course, the orchestration model. So basically, you orchestrate and you define as code what you want the system to do for you. So if you have a Python script that you want the system to execute, you have a provider that knows how to process Python scripts. If you have some work that uses some PowerShell, you have a provider. If you want to talk over MQTT, you have a provider. Now you say, okay, that's fine, Philip, but I want to build for my own specific system. Of course, go extend, build your own provider, and then you have the power of the object model, because as I mentioned, it's really a YAML file, and you just describe the work as code. Supports application topologies. You will see a couple. When I switch to the demo, you'll see what I mean by an application topology. But essentially allows you to describe how your environment looks like, what targets do you have, what applications are running on each one, and the dependencies between each of them. It has device capabilities. You register the devices, of course, right, so that you need to talk and orchestrate them. And then last but not least, we have been exploring a lot of the AI pipelines for this. It is a state-seeking engine. So basically, you define how your targets should look like in the system based on what you describe on this scenario as code, test as code, application, orchestration as code. He goes, make sure that the targets are always up to date to the state that you define. That means that if you have a version that you want a certain target to get, the system will just speak to the control plane and ask for that version. If you want to revert to a previous version, he also knows how to do that. And so basically, that's some of the capabilities that we built on Symfony. It has an information graph. Again, you can describe completely your orchestration topology, right? So you can think about even a scenario where you have your edge quarters with a couple of targets, then you have multiple subsidiaries, we have another set of targets, and so on. So you create essentially a federated architecture where with that topology, you can pretty much model the world, right, and have very complex scenarios where you want a certain test to run on a certain HQ or a certain subsidiary or a certain configuration. And that flexibility of the topology allows you to, for example, create essentially quite complex models where almost up to the point that you can bring the device or the car into the picture. Because again, if you want to then talk with the provider that talks into the car, and as long as the car is connected to a certain system, then Symfony will be able to go all the way down. Last but not the least, it's a workflow. We have approvals in it, so you can, for example, get the human in the loop if you need. It doesn't have to be everything automated. We have scheduled deployments. It supports, of course, canary deployments, and it's fully integrated with CI/CD. You might have your pipelines for orchestration might include some other tooling, like, I don't know, GitHub, for example. They are not competing to each other. They are complementing each other, and so Symfony can be part of a GitHub pipeline, or the GitHub pipeline can actually be part of the Symfony itself, giving you that full flexibility. And so in terms of architecture today, what do we have? So consider this is a project that we are still building, but of course, because it's open source, you are very welcome to make contributions to it. But today, the Symfony contains a CLI tool. We call it Maestro. So basically, through that CLI, you can essentially spin up a Symfony instance locally on your device as a developer so that you can start playing. It has a portal. The portal is not a portal that we think that you should would say, adopt, but consider the portal as our point of view on how you can take the advantage of the capabilities and build your own solutions. Because again, just to make it very clear, Microsoft is not building a first-party solution for automotive out of this. This is really for you to build your own solutions. It has several, as I was highlighting the examples of providers for shell scripting and Python, it has capabilities for scripting. You can build your own custom portals. It has a unified API. It has multiple protocol bindings. And then there are a couple of capabilities that I highlighted, like catalogs, like the solutions, the targets, and the devices. So with that, what I want to highlight as well before I go into the demo is that, as you see, it's really platform agnostic. You can orchestrate pretty much everything that you want as long as you are able to describe it as something that runs on a computer. So as I mentioned, if it's a binary, he will just orchestrate that binary. If it's a shell script, it will orchestrate. If it's an AI pipeline, it will orchestrate itself. So again, we don't impose any application format. We don't impose that you change your pipelines. It's really about how you make Symfony part of your existing developer workflow, inner loop, and if you want some extent, the outer loop. And of course, last but not the least, extend to your needs. So with that, I'm going to switch to that. Can you join the Teams call? And apologies for this, because my laptop is not able to connect to that. Yeah. Okay, so let me share my screen. So the Symfony portal looks like this, right? And I'm not going to go into too much detail. That's what I was said, that is our just experimentation. But what I want to highlight here from this is that when you click on for example, on the targets, what we describe in JSON is how we want our devices to look like. And this is coming from I use here on purpose a PLC and not an electronic control unit, just to make the point that Symfony is really industry agnostic, right? So you can use it across multiple industries. In the SDV space, we have seen that for toolchain orchestrations and for cloud-to-edge orchestrators, collaborating with Encaios, with Lucci, with Pulpiri from LG, we see a lot of opportunities. Basically, we've been collaborating together because we can help from the cloud side, while, for example, the LG with Pulpiri is specialized to run inside the vehicle itself. So in this case, what you see here is we have 4 different types of targets, right? So we register. So the instance type says I have 2 PLC targets. They could be, for example, running that very small agent of 4 megabytes that I was talking about. The Raspberry Pi is these days, and with the Pi 5, it's almost like a very large computer with 8 gigabytes of RAM, so you have it also registered. The provider target is really what I also want to call out. At the moment, it's called mock, but you can put the provider that talks with your specific device. So for example, if that Pi 4 needed to talk over MQTT, you actually had that instance, for example, registered as MQTT. We just added a feature in experimental branch where the providers can be dynamically loaded. So for example, if you want that Pi to be talking over MQTT and later on you need a certain test when you wanted to switch to some other protocol, you just load the provider on it. And then, of course, the Kubernetes that I mentioned. But the interesting thing that we have been working on is for example, with AVL, that architecture, so we built a Copilot, right? And we built a Copilot. I'm just using the interface of GitHub Copilot, but anything here that you will see, you can build with any generative AI framework. And so in this case, I have a Copilot that is registered again with a demo. I don't know let me get the prompts because I don't know them. And so basically what I'm going to say is, okay, please tell me which security test will be applicable to the device that is registered there. That's cool. So he was able to look at the DSL and the database and the information, and now the Copilot is saying, okay, for that specific device, some of the security tests can be applied. And remember, the use case we selected was the cybersecurity test case. So it gives you a couple of recommendations, what kind of security tests you can do. And then you ask him, for example, to create that one of the specific attacks based on that DSL language. And here it is. So he started, so basically he's looking at the DSL language, and if you remember from the presentation, this is the DSL. This is the DSL compiled with the target information. And this is more or less what the Copilot was able to do that. So I want to call out that this is a very basic retrieval augmented generation approach. There are a lot of opportunities for fine-tuned models, for large language models, for small language models, but that's the kind of information that you can get. So I'm a developer. I'm working with all of these. I'm looking at what I want to build. Then I need to build a UDS test diagnostic. And here it goes. Here it is. The other thing I want to call out is, again, this is an open source session. This is not a Microsoft product session. I want to make it clear. I'm using GitHub Copilot as an example, because I also realize that a lot of the developers are using GitHub today. And GitHub, as the Copilot tool, has a very extensibility model, and that's why I chose that option. But again, consider this as the approach and not necessarily as the product. So I've built now that UDS, and then what I want to do is, of course, create for me a Symphony campaign to orchestrate the above test. And now what is happening here behind the scenes is that Symphony just is now creating, and this is what I was referring as the object model, right? So this is the YAML file that Symphony knows how to process. Basically, it has that provider stage. It has multiple stages, and then within each one of the stages, you can send a couple of inputs, and you can ask the Symphony to execute. In this case, if AVL had a provider called stage UDS diagnostic, you'll just send the inputs, call the provider, go to the target, execute the test, get the results back, and that's it. So from the Symphony side, yes, running out of time. Yeah, sorry for that, guys. No, yeah, I'll just finish. It's just the other thing we are doing is, of course, from the Symphony side, you have run this against a certain system. We are bringing, again, the idea of a Copilot. It's not an interface. It's not how we want to do it. It's just to give you open source ideas for you to implement, because this is on the experimental branch already. And for example, if you want to come and say, okay, sorry, where is it's here. Yeah, I have too many. Okay, let me give all of these. You come here, and you say, I'm deploying that application or that test to a certain Pi, Kubernetes cluster, and to controllers. What Symphony objects do I need to use? And then he goes, he checks the system, and he comes up, hopefully, yeah. And he comes up, as you can see here, with the model that you need to build. So essentially from here, then these boxes are representations of those Symphony objects, and then from here what we can do is we have the developer or the Copilot helping the developer also building those applications. So you have a front door experience where the developer has assistance from the system, from the domain-specific language. It has knowledge of the orchestrator platform. It has knowledge of the targets. And essentially, hopefully, we think that is valuable for the community to start building these modern tool chains. So over to you.
Okay. So let me wrap up the talk. Okay, so let's go into the last part of the talk. So, like we told before, this approach is like general. So you can, we plan to apply it also for functional testing, for cycle runs, and for ADAS topics. And like I said before, this CI/CD pipeline can span over OEM and provider and supplier, so to enable better collaboration.
From Symphony roadmap, everything is public. Again, it's Eclipse. It's on the GitHub of Eclipse. You can go there, check that work item. You'll see our roadmap. But of course, we want to improve code quality, documentation, and test coverage. Because again, if we want to achieve FUSA, we think that quality is upmost, right? We all know all of that. The polling agent, we are working to improve it, and we want to ensure that the security posture is up to the challenges that we see today, because as you know, there have been multiple and more sophisticated attacks, and that's an area where we are focusing on. We have received a couple of feedback from the ecosystem so that we can build chaos tests from the Symphony itself, which is a quite interesting concept. And then last but not least, the provider SDK, so that we lower the barrier for you to extend, build your own providers. And of course, ideally with some help with generative AI, you can accelerate this. But nevertheless, it's all public. Go there, check. The primary developer of Symphony, Aishi, is on the conference. One of my peers on the group, Charlie, is also on the conference, so if you need, just reach out to us and we're happy to talk to you.
Okay. So the key takeaways are basically you can use the DSL from the OpenDOT project to create these abstract test templates and use it for your testing use cases. Then we have already today building blocks which are pretty mature in the software-defined Eclipse project and which are used today in our testing products to basically make the life of our customers easier. And then the last thing, a small invitation, look into OpenDOT, into the DSL, into Symphony, and see where it can help you. So, and with that, thanks a lot for joining the talk today.
Yeah, thank you.
So, Hannes, obrigado, Felipe. And I already saw some faces which were indicating that there are questions. What are those questions, gentlemen? We have 9 minutes left.
No questions.
Oh.
So question to Felipe, actually. So there's a lot of discussion around having a core stack, right, made of building blocks, and hopefully the building blocks are our project.
Mm-hmm.
Is Symphony a good way of doing variant handling, where you say, I have this empty black box, I want to take this version of this project that I know works with the other version of the other project and kind of build it together?
Mm-hmm. It's a great question. Yes, right? But what we would like to see is the community working with us and confirming our understanding. I've been collaborating across with Electrobit, with Red Hat, with LG. Our booth had an implementation of a provider with LG. But I also had the opportunity to get some inputs, for example, from Steven about how we think about Symphony. So we think that there's a strong opportunity for that. It can do what you do. That's basically how Symphony works, right? You define a set of targets, you define a state for that target, and then Symphony will just do the job for you. That definition, again, is not imposed by Symphony. You just describe it in the Symphony object model, those YAML files that you saw. The API is open, it's spec, right? So you basically can also extend it. And so we think that there's a strong possibility of collaborating to the project core, right? Which is essentially a tool chain that we all should have and collaborate together so that we can build large distributed systems, if I can put it this way, in a distributed way, right? Because we have to find a way to collaborate, and that collaborating issues, PRs, and all of that, I think Steven is doing a great job on how we can do that in open source. But then the tools are also critical because we don't want to spend too much time fixing tools. Last but not least, these core and tool chains, I think it's important to look at it from a platform engineering perspective. So SCORE and the tool chain is actually a product by itself that needs to be maintained, that needs to evolve, that needs to get feedback, because really what we want is to simplify our life as developers, right? So in the end, if we just have one tool, it's not maintained, 6 months later, no one is going to use it. So that's how we see that.
So, what are the resting questions? If you don't have one, I have one. You've been talking about you wish people to contribute to the project. If you have a wish, what would be the most appreciated contribution you would love to see?
Providers. So it's funny because when we work with multiple customers and members of the ecosystem, because we have a couple of providers out there, like, for example, running over MQTT or over HTTP, or people tend to default to use those. Although I think there is a strong opportunity to give you the flexibility and improve the dynamic loading of the providers that you need for the scenarios, test cases, targets that you have, right? That also is an opportunity, in my opinion, for monetization, because we are all here to make money, in my opinion, right? We collaborate in the open source, but then we work for companies. And the providers gives you that IP, but also gives you that flexibility of extending Symfony to the needs, and then we can actually work with you to make Symfony better and support more scenarios these days. We have seen that people just use the providers we have out there. They kind of work around their development to make it Symfony, and we would like to get the other way around. Bring what you need so that we see what you can do on Symfony to actually make Symfony work for you. So in the end, it's almost like that Uber idea that I think is quite important for us. We should work about specs and interfaces so that we can all collaborate together around with our tools and projects, and the other way around. I don't want to impose Symfony on anyone, right? You take it if you want, if you see value, but if you see value on it and you want to extend it, and then tell us what is missing. So the providers, we are working quite a lot. As you know, there are some limitations on Go to load dynamic providers. Or loading dynamic models. That's the reason why we built a provider in Rust. So just give us feedback on that. Start building with that. We are happy to collaborate with everyone. Build jointly blueprints, jointly projects, and that's where I would like to get the community to help us.
All right, so tell them how bad you like it.
Yeah, tell us how crap it is, and we'll make sure that we make it better.
I would have another one. If I got right what Symfony is doing, then in the end, very abstract words, and I like that area, it's reducing complexity, handling complexity for a developer, for a software integrator maybe.
Yes.
Do you have some experiments done and can quantify by what extent and by what level you reduce complexity? Do you have an example?
So we have been, so yes, the first thing is we started to run performance tests on Symfony to see how fast it can handle multiple executions and workflows, right? And we saw, for example, Symfony dispatching 25 requests in less than 5 minutes. That's one. And so, in my opinion, when you have a system that you can declare with YAML the workload that you want, and then give it the location to the tools that you want to orchestrate and have the system just take it care for you, we see huge gains on developer productivity on some prototypes that we built with customers, right? That's one area where it has been very well received. The performance and the scaling, that's another one, right? Because again, when you run large-scale orchestration systems, depending on the complexity of those, takes time. And again, Symfony, because it's lightweight, we built it lightweight. We don't want. It should be done, do one thing very well, and that's it. And so that's where we have been working on. We, for example, showcased 6 months ago in an Eclipse event how we orchestrated flashing a real-time operating system, or an MC. So we flashed an MCU, we flashed a Linux installation with an eBPF, we flashed a Windows application on another target, all part of the same application, and that is completed in a couple of minutes. And for us, again, it takes us probably just 1 hour to build that system. It's like that. You define the target, you put the agent on the target, or you have some way to put the agent there. You declare the YAML, and that's it. So I can easily build these demos while, for example, I'm on the train coming here. That's how we see the developers. And again, we have multiple customers within Automotive and outside now trying this at a very large scale, and we are getting a lot of good signals in terms of developer productivity.
Awesome, thanks. Last quick call for a question. If there's no more, then thanks again.
Okay, thank you.
Give them the more hand.
Thank you.